Welcome. Today we will start chapter number 8, that is state space methods. In this chapter we will study 4 different methods, that is direct programming, parallel programming, series programming and general programming. All are simple, it is not difficult. Therefore, first of all we will see problems on direct programming. They are very simple, not that much difficult. Therefore, please pay attention. Example 1. The dynamics of a helicopter in the hovering condition are described by the differential equation yt is equal to 1 divided by d plus 2 into d plus 3 into ft. Equation 1. Determine the computer diagram and state space representation by direct programming. Now solution. This is our equation 1. Yt is equal to 1 divided by d plus 2 into d plus 3 into f of t. Equation 1. The direct programming. In direct programming, x1 is taken as the differential equation in which numerator is 1. Therefore, we have to consider that, we have to assume that x1 is equal to 1 divided by d plus 2 into d plus 3 into f of t, which is equal to 1 divided by d square plus 5d plus 6 into f of t. Therefore, if x1 is equal to this value, that is 1 divided by d plus 2 into d plus 3 into f of 2, therefore equation 1 will become yt is equal to x1. Equation 2. Now the differential equation for x1 may be written as, therefore x1 into d square plus 5d plus 6 is equal to f of t. Therefore d square x1 plus 5dx1 plus 6x1 is equal to f of t. Therefore x1 double dot d means, capital D means d by dt. Therefore d square means d2 divided by dt square. Therefore x1 double dot plus 5x1 dot plus 6x1 is equal to f of t. Therefore put x1 dot is equal to x2. Therefore x1 double dot is equal to x2 dot. Therefore above equation becomes x2 dot plus 5x2 plus 6x1 is equal to ft. Therefore x2 dot is equal to ft minus 6x1 minus 5x2. Equation 4. Therefore the computer diagram for the above equation is, now what we have considered, yt is equal to x1 and x2 dot is equal to ft minus 6x1 minus 5x2 and x1 dot is equal to x2. Therefore considering equation 2, 3 and 4, we will draw the computer diagram. Therefore f of t is input to the summing point, its value is positive, output is x2 dot. Now integration, this in the box, this sign is integral sign. Integration of x2 dot is x2 which is equal to x1 dot. Similarly integration of x1 dot is equal to x1 which is equal to yt. Therefore yt is equal to x1. Now we have to write down the values, that is x2 dot is equal to, what is x2 dot? ft minus 6x1 minus 5x2. x2 dot is equal to what? ft minus 6x1 minus 5x2. Therefore from x1 we have to take one feedback signal, that is takeoff point, and therefore that feedback element value is 6, and that value we have to feed back to this summing point, its signal is negative. Similarly 5x2, therefore from x2 we have to take takeoff point like this, feedback element value is 5, and same signal we have to feed back to the summing point, that is its negative signal. Therefore x2 dot is equal to ft minus 6x1 minus 5x2. This is our computer diagram. The state space representation for equation 3 and 4 and equation 2 are as follows. X matrix of x1 dot x2 dot is equal to 0 1 minus 6 minus 5 x1 x2 plus matrix of 0 1 f of t, and y is equal to 1 0 x1 x2. Now example 2. The motion of a driverless vehicle which follows a wire embedded in the floor is described by the differential equation yt is equal to 2 into d plus 5 divided by d plus 2 into d plus 3 into ft. Determine the computer diagram and state space representation by direct programming. Therefore solution here yt is equal to 2 into d plus 5 divided by d plus 2 into d plus 3 into f of t, equation 1. Now what is our standard practice? Consider x1 is equal to, in the numerator we should consider 1. x1 is equal to 1 divided by d plus 2 into d plus 3 into f of t. Therefore x1 is equal to 1 divided by d square plus 5d plus 6 into f of t. Therefore this d square plus 5d plus 6 will be multiplied here into x1, and yt is equal to what will be our value? 2 into d plus 5 into x1. Therefore from equation 1 yt is equal to 2 into d plus 5 into x1. Therefore 2d plus 10 into x1. Therefore yt is equal to 2dx1 plus 10x1. Therefore yt is equal to dx1 means x1 dot, yt is equal to 2x1 dot plus 10x1, equation 2. Put x1 dot is equal to x2. Therefore yt is equal to 2x2 plus 10x1, or yt is equal to 10x1 plus 2x2, equation 3. Now x1 is equal to 1 divided by d square plus 5d plus 6 into ft. Therefore d square plus 5d plus 6 into x1 is equal to ft. Therefore d square x1 plus 5dx1 plus 6x1 is equal to f of t. Therefore d square means d2 divided by dt square. Therefore x1 double dot plus 5x1 dot plus 6x1 is equal to f of t. As x1 dot is equal to x2, therefore x1 double dot is equal to x2 dot. Therefore x2 dot plus 5x2 plus 6x1 is equal to f of t. Therefore x2 dot is equal to ft minus 6x1 minus 5x2, equation 4. Therefore considering equation 2, 3 and 4, we will draw the computer diagram like this. See that f of t, it will come to the summing point, its value is positive, output is x2 dot. Now integration of x2 dot is x2 which is equal to x1 dot. Again it is fed back to this forward path transfer function having integral sign. Therefore integration of x1 dot is equal to x1. Again it is fed back to this 10. Therefore 10x1, again summing point will be there, and at the end output yt will be there. Now yt is equal to, what is our output? Yt is equal to 10x1 plus 2x2. Therefore finally we should get that value. Now 10x1 we have got. Now from this x2 we have to take one signal and we have to feed back to this 2, and again this 2x2 is fed back to the summing point, its value is positive. Therefore yt finally we are getting it as 10x1 into 2x2. Now x2 dot is equal to what? ft minus 6x1 minus 5x2. Therefore from this x1 we have to take takeoff point, and we have feedback element value is 6, and we have to feed back to the summing point, its signal is negative. Similarly from x2 we have to take takeoff point like this, and feedback element is 5, its signal is negative, therefore minus 5x2. Therefore x2 dot is equal to my ft minus 6x1 minus 5x2, and yt is equal to 10x1 plus 2x2. Therefore this is our computer diagram. Therefore space diagrams for above equations are x1 dot x2 dot is equal to 0 1 minus 6 minus 5 into x1 x2 plus 0 1 f of t, and y is equal to 10 to x1 x2, that is 10x1 plus 2x2. This is the problem number 2. Now next is problem number 3. Determine the space representation for the feedback control system shown below using direct programming. Also construct the computer diagram. Now g of s is equal to 2 divided by d square plus 7d plus 10. This is our equation. solution. Here g of s is equal to 2 divided by d square plus 7d plus 10. Now we have this closed loop control system like this: f of t, summing point, after that g of s, then yt, then from this output we have taken takeoff point, feedback signal having h of s is equal to unity, its value is negative. Therefore from above diagram we can say that it is an example of minor loop of feedback control system. So its transfer function can be given as yt upon ft is equal to gs divided by 1 plus gshs. As it is an unity feedback system, hs is equal to 1, therefore yt upon ft is equal to gs divided by 1 plus gs. Therefore yt is equal to gs divided by 1 plus gs into ft, which is equal to 2 divided by d square plus 7d plus 10 divided by 1 plus 2 divided by d square plus 7d plus 10 into f of t, putting the value of gs. Therefore now by simplification we are getting finally yt is equal to 2 divided by d square plus 7d plus 12 into f of t, equation 1. Now finally we have got this equation. Therefore we have to consider that x1 is equal to 1 divided by d square plus 7d plus 12 into f of t. Therefore equation 1 becomes yt is equal to 2x1, equation 2. Therefore we will cross multiply here, that is this cross multiplication will be here. Therefore x1 into d square plus 7d plus 12 is equal to ft. Therefore d square x1 plus 7d x1 plus 12 x1 is equal to f of t. Therefore x1 double dot plus 7x1 dot plus 12x1 is equal to f of t. Therefore put x1 dot is equal to x2. Therefore x1 double dot is equal to x2 dot. Therefore we are getting the value as x2 dot plus 12x1 plus 7x2 is equal to f of t, or x2 dot is equal to f of t minus 12x1 minus 7x2. Now considering equation 2 and 3, we will draw the computer diagram. Now see that summing point here signal is positive f of t signal, output of summing point is x2 dot, its integration is there x2 dot integration x2 which is equal to x1 dot. Therefore integration of x1 dot is equal to x1, and again it is fed back to 2, and output yt is equal to, so that yt is equal to 2x1. This is our equation, equation 2. Same output we should get. Therefore yt is equal to 2x1. Now x2 dot is equal to what? ft minus 12x1 minus 7x2. Therefore from this x1 we have to take one signal, takeoff point, and in between that backward path we have to provide one element, its value is 12, transfer function. Now its signal is negative. Similarly x2, from x2 we have to take takeoff point and we have to feed back to summing point along with the transfer function 7. Therefore 7x2 dot, its signal is negative, therefore minus 7x1 7x2. Therefore x2 dot is equal to ft minus 7x2 minus 12x1. Therefore this is our computer diagram. Therefore space representation for the above equation is x1 dot x2 dot is equal to 0 1 minus 12 minus 7 x1 x2 plus 0 1 f of t, and y is equal to 2 0 x1 x2. Therefore these are the problems on direct programming. Now we will see problems on parallel programming method. Examples on parallel programming. Now parallel programming, name itself indicates that in the computer diagram two loops will be there and that two loops will be in parallel. Now example 1, the motion of a driverless vehicle which follows a wire embedded in the floor is described by the differential equation yt is equal to 2 into d plus 5 divided by d plus 2 into d plus 3 into f of t. Determine the computer diagram and state space representation by parallel programming. Therefore We will solve this example by parallel programming. Solution here, yt is equal to 2 into d plus 5 divided by d plus 2 into d plus 3 into f of t, equation 1. Now, in case of parallel programming, we have to use partial fraction method. Therefore, let 2 into d plus 5 divided by d plus 2 into d plus 3 is equal to a divided by d plus 2 plus b divided by d plus 3, equation 2. Therefore, by using cross multiplication, a into d plus 3 plus b into d plus 2 divided by d plus 2 into d plus 3. Therefore, 2 into bracket d plus 5 divided by d plus 2 into d plus 3 is equal to ad plus 3a plus bd plus 2b divided by d plus 2 d plus 3. Therefore, these two denominators are going to vanish or they will cancel with each other. Therefore, we will get, after comparing coefficients of numerator on both sides, we will get 2d plus 5 is equal to 3a plus 2b plus d into bracket a plus b. Therefore, 2d plus 10 is equal to a plus b into d plus 3a plus b. Therefore, a plus b is equal to 2 and 3a plus 2b is equal to 10, equation a and b. Solving above equations to find out values of a and b. Therefore, multiply equation a by 2. Therefore, b term will get cancelled. Therefore, we are getting finally a is equal to 6 and b is equal to minus 4. Now, therefore, from equation 1, yt is equal to 2 into bracket d plus 5 divided by d plus 2 into d plus 3 is equal to 6 divided by d plus 2 minus 4 divided by d plus 3 into t. Therefore, yt is equal to 6x1 minus 4x2, equation 3, where x1 is equal to 1 divided by d plus 2 into ft and x2 is equal to 1 divided by d plus 3 into ft. Now, cross multiplication, x1 into d plus 2 is equal to ft. Therefore, dx1 plus 2x1 is equal to ft. Therefore, x1 dot plus 2x1 is equal to f of t. Therefore, x1 dot is equal to f of t minus 2x1. Similarly, here d plus 3 into x2 is equal to f of t. Therefore, dx2 plus 3x2 is equal to f of t. Therefore, dx2 means d by dt. Therefore, x2 dot plus 3x2 is equal to f of t. Therefore, x2 dot is equal to f of t minus 3x2. Now, x1 dot x2 dot values we have got. Now, we will draw the computer diagram. See that f of t, that signal is common. It is fed back to the two summing points. Since this is parallel programming, two parallel loops will be there like this. Therefore, from first summing point, output is x1 dot, its integration is x1. Again, it is fed back to this element 6, and again summing point is there, so that yt is equal to 6x1 minus 4x2. Again, at the bottom also, f of t signal is fed back to this second summing point here. x2 output, its output is x2 dot. Therefore, integration of x2 dot is x2. Again, it is fed back to this feedback element or the forward path transfer function 4, and again it is given back to this summing point. Its value is negative, that is minus 4x2. Now, we are knowing that x1 dot is equal to ft minus 2x1. Therefore, from x1 we have to take one signal. From this we have to take one signal, and this 2 we have to feed back to this, or we have to give the signal to this transfer function having value 2, and this signal is again fed back to this first, that is summing point at upper level. Therefore, x1 dot is equal to ft minus 2x1. Similarly, x2, from x2 we have to take off one signal like this, and then we have to feed back, that is this value of transfer function is 3 and its signal is negative. Therefore, x2 dot is equal to ft minus 3x2. x2 dot is equal to ft minus x2 dot is equal to ft minus 3x2. Therefore, same value is here, ft minus 3x2. Now, since these two loops are parallel, this is known as parallel programming. Therefore, state space representation is x1 dot x2 dot is equal to -2 0 0 minus 3 x1 x2 plus 1 1 f of t, and y is equal to 6 minus 4 x1 x2. Therefore, this is the first problem on parallel programming. Remember that in parallel programming we have to use partial fractions so that we can determine the values of x1 dot and x2 dot. Now next problem, say example 2 on parallel programming. The dynamics of a helicopter in the hovering condition is described by the differential equation yt is equal to 1 divided by d plus 2 into d plus 3 into f of t. Determine the computer diagram and state space representation by parallel programming. Therefore, yt is equal to 1 divided by d plus 2 into d plus 3 into f of t. Now, for parallel programming, 1 divided by d plus 2 into d plus 3 is equal to a divided by d plus 2 plus b divided by d plus 3, which is equal to a into d plus 3 plus b into d plus 2 divided by d plus 2 into d plus 3, which is equal to ad plus 3a plus bd plus 2b divided by d plus 2 into d plus 3, which is equal to d into bracket a plus b plus 3a plus 2b divided by d plus 2 into d plus 3, and on left hand side same value is there, that is 1 divided by d plus 2 into d plus 3. Therefore, 1 divided by d plus 2 into d plus 3 is equal to d into bracket a plus b plus 3a plus 2b divided by d plus 2 into d plus 3. Comparing coefficients, we have a plus b is equal to 0 and 3a plus 2b is equal to 1. Therefore, solving equations a and b, that is multiply equation a by 2 and subtraction. Therefore, we are getting a is equal to 1 and b is equal to -1. Therefore, from equation 1 we have yt is equal to into bracket 1 divided by d plus 2 minus 1 divided by d plus 3 into ft. Therefore, yt is equal to x1 minus x2, equation 2. Therefore, x1 is equal to 1 divided by d plus 2 into ft. Therefore, cross multiplication d plus 2 into x1 is equal to f of t. Therefore, dx1 plus 2x1 is equal to f of t. Therefore, x1 dot is equal to f of t minus 2x1. Similarly, here this is equation 3. x2 is equal to 1 divided by d plus 3 into f of t. Therefore, x2 into d plus 3 is equal to f of t. Therefore, dx2 plus 3x2 is equal to f of t. Therefore, x2 dot is equal to f of t minus 3x2, equation 4. Therefore, now we will draw computer diagram of this yt for equation yt is equal to x1 minus x2, for equation x1 dot is equal to ft minus 2x1, and for equation x2 dot is equal to ft minus 3x2. That is, for equation 2, 3 and 4 we will draw the computer diagram. Therefore, f of t is the common, it is fed back to this summing point, both the summing points. Now first of all we will see upper part, x1 dot, its integration is x1. Again it is fed back to this summing point here, signal yt, its value is, signal is positive. Now x1 dot is equal to what? ft minus 2x1. Therefore, from this x1 we have to take one signal and its value should be 2x1 or minus 2x1. Therefore, these two elements should be multiplied here and this value of signal is negative. Therefore, x1 dot is equal to ft minus 2x1. Similarly, at the bottom, signal ft is fed to this summing point, x2 dot, its integration is x2. Again same is fed back to this summing point from which output is yt. Now signal of x2, value of signal of x2 is negative. Now we are knowing that x2 dot is equal to ft minus 3x2. Therefore, from x2 we have to take the signal and we have to put one block having its value as 3 and its signal should be negative. Therefore, x2 dot we are getting as ft minus 3x2. Therefore, this is the computer diagram and this is the end of the parallel programming method. Now only two methods are remain, general programming and series programming, that we will see in the next lecture. Thank you very much.